Hi guys, welcome. It's week 6 that we are looking at. So we have 3 lessons to get through this week, 94 for the first, and then 95 and 96. Okay, so let's flip over to lesson 94. We are writing fractions and decimals as percents part 2. So this is something we've been doing really all year, even on some of our tests we've had where we're given a decimal, we have to find the percent and fraction or vice versa. So we've been doing a lot of it, so nothing brand new. A fraction can be expressed as percent or a decimal, just depending on what the problem is asking for or if we're choosing. Sometimes it'll be better to make a number into a fraction, sometimes into a decimal. It just kind of depends. So again, how we can figure out what a fraction equals, we can do it a few different ways. So 3/5, we want to figure out, okay, 3/5 as a percent. The percent is per 100, so we can multiply by 100 over 1, multiply by 100, just like we do with a decimal number. And that gives us 300 over 5, which 300 divided by 5 is 60. That's one way. The way I would do it, because it's just I've always done it, maybe a bit quicker and easier. So if I do 3 divided by 5, because 3/5 is just 3 divided by 5, and I get 0.6, and then I know I multiply that by 100 and move the decimal over 2 places to the right, is 60%. So that's the way I would do it. So doing 100 over 1 and then doing the division, I just do 3 over 5, I know it's 0.6, so I can easily figure that out, and then move the decimal 2 places to the right because we are multiplying by 100. Either way, some of these are just kind of personal preference. Decimals to percents and percents back to decimal, I think, are the easiest just because we're really only moving the decimal place. So if I have 0.375 and I want to make it percent, yes, I'm multiplying by 100, but I don't even really have to do this in a calculator or write it out by hand. If I can just remember there's 2 zeros, I'm multiplying, so I move the decimal 1, 2 places to the right. We move it 2 places to the right. Of our own, let's say we have 52.3%. So there's a decimal in the percent, but that's okay. We want to make this a decimal, and we're going to move the decimal 2 places to the left. So this percent as a decimal is this. Or if I was given this decimal and wanted to make it a percent, I would just move it 2 places to the right to 75.5%, or whatever the number is. So that one, I think those are always the most kind of user-friendly because we don't even have to multiply. We are multiplying or dividing by 100, but really we don't even have to do that calculation if we just remember dividing by 100, moving 2 places to the left, multiplying by 100, moving 2 places to the right. Okay, so if we want to make 1/3 as a percent, and this one might be a little tricky because it's a repeating decimal, but we could do 1 divided by 3, and that equals 0.3 repeating. So 3, 3, 3, 3, 3 on forever. So we move the decimal 2 places to the right, we get 33.3 repeating percent. Or if we want to do 1 100 divided by 3, 3 goes into 133 times, which is 99, so there's 1 left over. So 33 and a third percent. Same thing, either way you want to get there. It's a repeating decimal, but that may be the time where it's easier to use the other method versus just dividing. We don't really have a way to put 0.3 repeating forever into our calculator. 1.2 is a percent. 1.2 is a decimal. We want to make it a percent, so we're multiplying by 100, or we can remember that we're just moving it to the right because it's getting bigger. In this little empty space, we fill in a 0, 120%. And that makes sense because 1.2 is greater than 1. So 120% being greater than 100%. And we can work with percentages. Even though percent means per 100, there are kind of examples where we can go above that. 2 1/4 as a percent. So 2 1/4. We can make this 225 over 1, so 225%. So we had to make it an improper fraction from a mixed number multiplied by 100. Another thing we can do, we know 1 divided by 4, or 1/4 is 0.25, so we can call this 2.25 and then move the decimal 2 places to the right. Get 225%. Same thing we got up there. So again, more than one different way to go about solving this. Always look back and make sure that it makes sense, whatever you do. Okay, 2 1/6, that's another one of our repeating decimals. We get 13/6, and we make it an improper fraction multiplied by 100. 1300 divided by 6. 6 goes into 1300, 116 times with 2 left over. With 4 left over being divided by 6, so it reduces down to 2/3. 20 of the 30 students in the bus were girls. What percent of students in the bus were girls? 20 of the 30, so we can reduce that down to 2/3 were girls. Multiply this by 100, so 200 over 3. Oh man, 3 goes into 26 times, with 2 left over, it goes into 20 again. Just 18 with 2 left over, so 66.6 repeating forever, or 66 2/3%. 95, reducing rates before multiplying. This is really something that I've shown you all year just because it's the method I prefer. When we're multiplying things out, let's say we have well, we could already reduce that. So. Something like this. So we could do 5 times 2 is 10 over 8 times 15, which is 120, and then factor out a 10 and get 112. We could do it that way. Nothing wrong with that, just sometimes doing a lot of multiplication just to reduce it down after we've multiplied. So we're kind of creating more work to create more work. So one thing we can do, if there's a fraction, obviously reduce top and bottom. But when you can't do that, you can look diagonally because eventually these two numbers are going to be multiplied over these two numbers, or 3 or 4, however many numbers. So we can look diagonally and see 5 goes into both of these. Goes into 5 once, 15 3 times. 2 and 8, well, 2 goes into 2 once, and into 8 4 times. 1 times 1 is 1, over 4 times 3, which is 12. So we get to the same answer if we do everything correctly. It's just I think this way is easier versus getting to the end where you have a large number in the numerator and the denominator, and then you're trying to work to find the greatest common factor, or just any factor, and reducing and reducing and reducing until you get there. Okay, we also cancel out units when we're multiplying. That's why we use unit multipliers to get rid of units. So if we're going 4 miles an hour for 2 hours, hours and hours, we're going to 4 miles an hour for 2 hours, we're going to end up with a distance, miles. Okay, so hours and hours are going to cancel. So you walk at 4 miles an hour and you walked for 2 hours. How far did you go? And you said 8 miles per hour. I'd go, wait, what? Hours cancel out. So we're left with just 8 miles in this example. 55 miles per hour, 6 hours, so 55 miles per hour. And we can write MPH, or for this, we probably want to see it in fraction form, by 6 hours. So hours and hours, one's in the numerator, one's in the denominator, just like any number divided by itself cancels out because it's just one. Same thing with units. Hours over hours would cancel out. So we're left with 55 times 6, which is 330. And we haven't got rid of miles, which makes sense if we're saying driving 55 miles per hour for 6 hours and traveling 330 miles. Makes sense. 5 multiply 5 feet by 12 inches per foot. So basically, this is where we said we use unit multipliers. I'm going to convert 5 feet into inches. I'm going to use a unit multiplier. I know I want feet in the denominator because it's in the numerator right here, and I'm going to cancel it out. So 12 inches is equivalent to 1 foot. It's unit multipliers, so 12 inches and 1 foot are equal, so that's why we use it. Feet and feet would cancel, and left with 5 times 12 inches, which is 60 inches. So sometimes we do these conversions without even realizing that we're using a unit multiplier, but this is what we're doing when we do that. We'll go over those practice set problems in class. And the last lesson we're looking at is function and graphing functions. This is where having graph paper to help you out. So the graph, even if you do the best you can to be neat, sometimes it is difficult. All right, so looking at a function, basically for it to be a function, it can be a line, it can be a parabola, it can be a lot of different things. We have what's known as the vertical line test. So for graphing something, I know we're not jumping a little bit ahead of what we have, but if we have a line right here, and we draw a vertical line anywhere on the function and it only crosses one point, yes, it does. So that means it's a function. And if we have something like this shape, and we're going to use the vertical line test, oh, it crosses 2 points. So this would not be an example of a function. It's jumping a little bit ahead of where we are. So the rule or the function, we can be given points, work backwards to find the rule. We can be given the rule of the function and try and find points along the function. Find the rule for this function, then use the rule to find the value of m when L is 7. Okay, so 5 times 4 is 20, but 10 times 4 is not 25. So again, don't just look at one point, you have to look at multiple points. 5 plus 15 is 20, 10 plus 15 is 25, 15 plus 15. Okay, so for every L, we're adding 15 to M. So 17 would be 22. Find the missing number here. We have 2 and 4, 3 and 7. Here for X, and then for our input, X, and then our output, 3X minus 2. So 3 times 2 is 6, minus 2 is 4. 3 times 3 is 9, minus 2 is 7. 4 in for X, 3 times 4 is 12, minus 2 is 10. And when we're graphing functions, then we've looked at a coordinate plane where coordinate plane, we've used number lines before where it's just one-dimensional, left to right. That is our x-axis. Now we're adding a second dimension, x and y. So our ordered pairs are written like this. So whatever this value is our x value. That tells us how many we're moving left or right. And then this is our y value telling us how many we're moving up or down. So if we have 2, -3, because we're moving over 2 to the right because it's positive, and then down 3 for our y value. But that is our point right there. 2, -3, or whatever the example is. Oh, back to that. Other things I wanted to add. So x and y is vertical, x is horizontal. We call this the first quadrant. X and y are both positive. Over here, x is negative, y is still positive. This is the second quadrant. This is the third quadrant down here. Over here, x and y are negative. And then over here, x is back to being positive, but y is still negative. And this is the fourth quadrant. Okay, so just a brief introduction to the coordinate plane, but when we're graphing, we have one of our variables, which is known as the input, or the independent variable, that affects the other one, which is the output, or the dependent variable. And so if I put in 1, I multiply it by 4. So whatever I put in for s, I multiply by 4 to get p. So 1 times 4, 2 times 4, 3 times 4, 4 times 4. And then I plot those points, and then we can connect it. In that example, it would be a linear graph. Example 3, the perimeter of an equilateral triangle is a function of the length of its sides. Make a table for the function using the side lengths 1, 2, 3, 4. So equilateral, all sides are the same. So if the side is 1, our input, the output is 3. So 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. That's our input and our output. And then we can graph those as S, again, when we're making a table. We usually use X and Y. Sometimes if it's like side and perimeter or something like that, we can use the S and P. We always put our X, or our input, our independent variable, over here, and our dependent variable, or our output, over here. And so it was 1, 3, 2, 6, 3, 9, and so on. If it's linear, we need at least 2 points. If it's a different shape, we may need a bunch of points in order to graph it. Okay, so if those are our points, it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. And so X, we're calling S, Y, we're calling our P. So we go over 1, up 3, over 2, up 6, over 3, up 9. And you can see it's linear. It's going to continue on going that way. Okay, so as the side length gets bigger, perimeter gets bigger, which makes sense. And there's a way, I guess I can quickly, so that the rule for this would be y equals 3 times x, because whatever x is, we multiply it by 3 to get y. When we have that, we can put that into our calculator. So we go y equals, that's this button up here. So y equals, and then under 3, on the x button, you can do alpha x, or this button right below link right there, 3x. Make sure all your stat plots are turned off, and graph, and there's your line. We'll do a lot of graphing with the calculator. When you get into high school, you'll do a ton of graphing in this, so you get very comfortable with some of these different features. But I just wanted to show you what it looks like. The calculator can be very helpful for finding range or intersections or minimum points or some of those different things when we are graphing. The practice set we will do together, and that is all that we have for this week. See you guys in class.